Take a deep breath. That 21% concentration of oxygen in your lungs is the fuel that powers every cell in your body. We treat this breathable sky as a permanent geological fixture of our planet. But for the first 2 billion years of Earth's history, taking that same breath would have been fatal. The early sky was an alien haze of methane and hydrogen, a world where modern life would suffocate in seconds. Oxygen is chemically volatile. It does not naturally persist in the air. It binds with minerals and rocks to form oxides, effectively scrubbing itself out of the atmosphere as fast as it appears. Because oxygen naturally disappears, the air we breathe today is the product of an active biological terraforming project, a continuous chemical intervention that has been running for billions of years. That project began 3 billion years ago when cyanobacteria developed oxygenic photosynthesis. These microbes use sunlight to split water molecules, releasing O2 into the ocean. This oxygen didn't reach the sky at first. It was locked in a kinetic competition, consumed by geological sinks like volcanic gases. Eventually, the biological source flux overwhelmed these sinks. They clogged, and free oxygen finally accumulated in the atmosphere. Geologists can see this shift in the rock record. Around 2.3 billion years ago, continental rocks transform into red beds, vibrant layers of oxidized iron, confirming oxygen had moved from the sea to the land. As oxygen levels rose, photochemical reactions in the upper atmosphere began forming a stratospheric ozone layer. This new shield blocked the lethal ultraviolet radiation that had previously sterilized the Earth's surface. Life's first victory in engineering the atmosphere had permanently altered the planet's chemistry. But this transformation inadvertently triggered a massive ecological crisis for the anaerobic microbes that had ruled the early Earth. This chart shows atmospheric oxygen over time. Following the Great Oxygenation Event, O2 collapsed to a near-zero flatline for 1 billion years. During this standstill, a severe shortage of oxygen and nutrients pushed primitive life to the edge of collapse. To survive this extreme stress, simple cells merged. They developed specialized internal structures to become eukaryotes, the complex precursors to all higher life forms. These organisms developed sexual reproduction and early multicellularity as survival strategies, allowing them to shuffle their genetics and share limited resources more efficiently than their ancestors. These stress-induced adaptations were the non-negotiable prerequisites for complexity. Without the hardship of the boring billion, the biological tools required to build macroscopic life would never have evolved. Around 800 million years ago, the oxygen line rockets upward. Complex eukaryotes effectively buried organic carbon in the deep ocean, allowing O2 to surge. Reaching these high concentrations crossed a critical threshold, providing enough high-octane fuel to support large-bodied animals. This triggered an explosion of life. Within a geological blink, simple microscopic mats were replaced by diverse marine animals, actively swimming and crawling. This was the completion of the feedback loop. Biology engineered the planet's chemistry, and that new chemistry allowed biology to become macroscopic and complex. The ultimate demonstration of biological terraforming occurred during the Carboniferous period, when massive forests of giant lycopsids and ferns established a firm grip on the land. As these forests grew and died, massive quantities of dead wood were buried in low-oxygen swamps. This carbon was locked deep underground, preventing microbes from using oxygen to decompose it. This imbalance caused oxygen levels to spike to 35%, far higher than the air we breathe today. This hyper-oxygenated atmosphere allowed insects to bypass the normal limits of their respiratory systems. The result was an era of gigantism, dominated by dragonflies with the wingspan of eagles and car-sized millipedes that thrived in the dense, high-pressure air. As these forests shifted and carbon burial rates stabilized, the oxygen concentration settled into the 21% equilibrium we see today, a finely tuned byproduct of a global biological engine. Life on Earth did not passively adapt to a hospitable rock. Through endless cycles of stress and innovation, biology manufactured the exact environment necessary for its own existence.